Hi there folks, my name is Z and welcome to the 9th nonplussed episode of I Don't Know and You Can Too. Today's episode is brought to you by the spontaneous failure of this electronic tripe right here in front of you. I just fixed this about 2 months ago, so I shouldn't have this problem, but I guess I need to get a dehumidifier for down here because it keeps making this sensor fail. Now, after the last time this one failed, I got a vapor alarm for down here, like a fire detector, but for vapors, to make sure that we don't actually have gases down here that's making this fail, and it is just the moisture. Now, I could call out a service tech to come fix this, because I called the stores and nobody sells this. They tell you gotta call a service tech to get it. They want about $100 to show up and then like $100 for the part. I can order the part myself on eBay for about $20, so I ordered two of them since apparently I'm going to have to replace this periodically. But I can't be waiting a month to have hot water, so I'm going to see if I can bypass this temporarily until the other sensors come in and I can replace it properly. Now, I shouldn't have to say this. If there's any possibility at all that you have any kind of flammable gases around, you should not attempt this bypass in any way, shape, or form, because that sensor is there for a reason. But I can't keep you from being stupid if you're going to be stupid. But I'm going to see if I can fix this. Let's do it. Alright, so I got this out, and we're going to see if we can fix it. Now, the way this thing works, for lack of a quicker explanation, is it's a chemical resistor. When it gets exposed to flammable gases, or in my case, water vapor, the resistance of the material inside increases, and when it gets to a certain level, the machine cuts it off. I looked up the documentation for the board that's inside this, and it says that it'll accept a resistance between, I think it said 5,000 and 50,000. Don't quote me on that. I should have printed it out. So what you can do with this is, if you have resistors lying around, you can just put between a 5 and 50,000 resistor in here, and you should be able to start the machine until you get fixed. I don't have one of those lying around right now, so I'm going to be trying to fix this with a dirty little hack. Let me get this all apart and we'll show you that. Okay, now to get this out, I just pushed this piece through with my thumb and then took a flathead screwdriver and worked it around the edge of this to crack the top off of it. Now you can see the rust from the water vapor, and that's what's caused this to fail. So I'm going to clean this side off, and then I'm going to show you how you can do this with something that you probably have sitting around your house that nobody thinks about. Now, to clean off this material they have on there, you can literally just use a piece of tissue and wipe it off until you got something that's clean. And now we need to turn this back into a resistor, complete this connection between these two. And the easiest way to do that is actually with just a pencil. Graphite is conductive, so if you get the line on here right, I'm going to grind a bunch of this on here. If I get enough of it on here the right way, it will complete this connection again, and I should be able to get this to run until my replacement comes in. Now, the way I'm going to test the resistance on this is with this multimeter I got for free from Harbor Freight, and we'll see if we've got this in the acceptable ranges. Alright, so I've got the multimeter on the correct setting this time, and I've got the graphite, just pencil lead, on here. And as you can see, right now it's reading at about 3,000 ohms resistance. And so now I need to get that up to between 5 and 50. So I'm just going to lightly with my finger brush that a couple of times. Let's see, that's brought it up to 3,500. Let's brush that a few more, thin that graphite out just a little bit more. So the graphite works as a conductor. So there we're at 5,300. Let's get that just a little bit thinner. I'd like it somewhere closer in the middle. Let's see if we can get that to like 10,000, 6,000, 7,000, 9,000, 10,000. Alright, now I'm just going to hook this whole thing back together for right now. I'm going to go plug it in the machine and we'll see if it'll let the machine start. Now I unplugged the water heater while I was doing the repair on this resistor. If you're not familiar with the restart process for these Rheems and this Honeywell, you unplug it for at least a minute, and then when you turn this back on, you've got to turn this from full and all the way to down and back 7 times within 30 seconds, and then that'll make this system reboot itself. So we're going to see if that repair has worked. Now this should go from blinking 7 times and then pausing for 3 seconds to just blinking periodically if this repair has worked. So let's see if this does it. And the pencil lead trick has done it. Alright, the machine's running. Now, like I said, this is only a temporary fix. I'm only doing this because I'm waiting for parts to come in. If you're in an emergency and you need it to work, you can do this. But like I said, you really should replace this with the right part. But it was something that needed done. We can't not have hot water. So as I always say, if it's worth doing poorly. If you liked today's episode, go ahead and hit that like and subscribe button. Give me some messages in the comments on if you have any ideas for upcoming episodes, or if you just liked today's episode. Thanks for watching, guys. I'll catch you all in the next one.